Alright, this is video R7, and it is the review of probability for our Algebra 2 EOC. So, we're going to do a whole lot of different topics very quickly. So hopefully you will find all of these fairly simple, but we're going to cover a lot of material in a short amount of time. So, beginning with basic probability. Basic probability can be summarized with the statement, probability is equal to desired outcomes over possible outcomes. And one of the most standard ways of describing probability is with a bowl of colored marbles. So here's my bowl of colored marbles, and let's look at what I've got here. I've got 1, 2, 3 red marbles, 2 blue marbles, and 4 yellow marbles in my bowl. That gives me a total of 9 marbles. So if I want the probability of drawing a blue marble out of that bowl, if I just randomly pick a marble out of the bowl, that probability would be 2, the desired outcomes, how many blue marbles there are, over 9, the total number of marbles in the bowl. Pretty simple. The probability of yellow would be 4, because I've got 4 yellow marbles, over 9 because I have a total of 9 marbles. What if I wanted to know the probability that I get all 3 red marbles, a red one and another red one and another red one? If I don't put the marbles back in between, that means the first time I draw a red marble out, my probability is 3 out of 9, 3 red marbles out of 9 total. But if I don't put that marble back, I don't have 3 red marbles left in the bowl. I've only got 2 red marbles left in the bowl and 8 altogether. So the probability that the second one is red is 2 out of 8. The probability the third one is red is only 1 out of 7. Now when we do AND probabilities, I want the probability the first one's red and the second one's red and the third one's red. I multiply those probabilities together. So that gives me a probability of 1 out of 84. Now, what if I put the marble back every time? I draw a marble, put it back, draw another marble. The probability then that I get all red ones there with replacement, I'm replacing the marble in between, is 3 out of 9 times 3 out of 9 times 3 out of 9, which gives me 1 out of 27. A lot greater chance of getting 3 red marbles if I put the marble back every time. What about the probability of getting red or blue? If you're doing an OR probability, add the probabilities together. And that should be kind of intuitive here. If I look at this, the probability of getting red is 3 out of 9. The probability of getting blue is 2 out of 9. I add that together, I get 5 out of 9. Well, all right, red or blue, how many marbles have I got? I've got 5 red or blue marbles out of a total of 9. So my probability is 5 out of 9. Well, what if the events that we're looking at are not mutually exclusive and I'm looking for an OR? Okay, mutually exclusive. In our previous example, if we go back and we look at our marbles over here, do I have any marbles over here that are red and blue? Okay, so all of these marbles are mutually exclusive choices. But that's not always the case in every example that we use. What if we look at a deck of cards? Cards have 52 cards, there are 4 suits, there are 13 different kinds of cards, ace through 10, jack, queen, king. What's the probability of getting a queen? Well, the probability of queen is 4 because there are 4 queens in the deck out of 52, or 1 out of 13. What's the probability of getting a heart? Well, of the 4 suits, one of them is a heart. There are 13 hearts in a deck. So the probability of drawing a heart is 13 out of 52, or 1 out of 4. What's the probability of getting a queen or a heart? Well, we said we added probabilities when we were doing an OR. The probability of getting a queen is 4 out of 52. The probability of getting a heart is 13 out of 52. So if we just add those together, we get 17 out of 52, but there's a problem. There's a queen of hearts in this deck. These are not mutually exclusive events. I have counted the queen of hearts here as a heart, and I've counted it here as a queen. You have to subtract out these duplicates. So I've got to subtract that queen of hearts. So if you're doing an OR and they're not mutually exclusive events, you've got to subtract out the AND. The chances that both of those happen at the same time. So we get 16 out of 52 or 4 out of 13. And you multiply or you add. If they're not mutually exclusive, don't forget to subtract the and or the chances of them both happening at the same time. We make predictions a lot of times using probabilities. Let's say you do a survey of your class. Favorite ice cream flavor. 5 pick vanilla. 13 of them are really smart and pick chocolate. 4 pick strawberry. And 3 pick something weird. Maybe they pick cookies and cream or, I don't know, chocolate chip or mocha or some weird thing like that. Well, the probability of vanilla, we do this just like we've done all of our other probabilities. Desired outcomes out of total outcomes is 5 vanilla, out of 25 the total, or 1 out of 5. The probability they pick vanilla or chocolate, 5 out of 25. It's an or, so we add, plus 13 out of 25. We get 18 out of 25. But what if we're asked to make a prediction? Maybe we're asked to predict the number. If there are 300 people in your senior class, predict the number of those kids who would choose chocolate. Well, we take the probability of chocolate, which is 13 out of 25, times the total number in the class. Gives me 3,900 over 25, or 156. We would expect 156 of those seniors to pick chocolate as their favorite flavor of ice cream. Conditional probability. Conditional probability means that we have something happens given something else has already happened. When you see this straight up and down line, that's conditional probability. We're wanting the probability that A happens given that B has already happened. And the formula for that is the probability they both happen over the probability that this item right here, this B, has already happened. So let's say that we look at statistics from algebra test, first test of the year, 90% pass. That's my first item. And 84% pass both the first and the second test. What's the probability somebody passed the second one given they've already passed the first? All right, so this 90% is my B here. It's what's already happened. And my probability of A and B is this 84%. This is the probability of A and B. I want to know what's the probability that A happens. They pass the second test, given that B has already happened. They pass the first test. So the probability of A given B. Well, the probability of A and B, 0.84. Probability of B, 0.9. So the probability of A, given that B's already happened, is 0.84 over 0.9, or 0.93. Make sure you get what's already happened on the bottom. Conditional probability. Complements. Complements are the probability of a not, the probability that something doesn't happen. And the probability of something not happen is simply 1 minus the probability that it did happen. So if I say the probability of, and we read this as B prime, or the complement of B, the probability that B did not happen is 1 minus the probability that B did happen. Well, let's go back and look at our thing over here. We use the probability of B as being 90%. Probability somebody passed the first test. So what's the probability they did not pass the first test? Well, 1 minus the probability that they did pass the first test. So we get a probability of 0.1. Fundamental counting principle. One little extra topic here. If you're trying to figure out how many ways something can happen, the fundamental counting principle says instead of writing out all your choices and just counting, then you can multiply your choices together. So if I'm trying to make a sandwich, this is one of my favorite examples. Let's say we're making a sandwich. We've got 3 different kinds of bread to choose from. We've got 3 different meats to choose from, 2 different cheeses to choose from. And I want to know how many different kinds of sandwiches can I make if every sandwich has bread, meat, and cheese on it. Well, I just multiply the choices together. 3 times 3 times 2. 18 different sandwiches I can make. You see this all the time with how many different outfits can I make given a certain number of pants or shirts and shoes. Just multiply all your choices together. Fundamental counting principle says if I multiply them all together, I can figure out how many ways they can happen. Last few, almost done. Combinations. Combinations are how many different ways can I choose out of a group. This is NCR. And remember, combinations, choose is the C. Let's say that I have 6 people and I want to choose 2 of them to be on a committee. Then this would be 6, the total number I have, choose 2. How many ways can I pick 2 people out of those 6? There are 15 ways I can do that. The order in this doesn't matter. I'm just choosing how many different ones of them I have. If the order matters, it's called a permutation. P, place in order. Permutation. NPR. These, by the way, are on your calculator if you don't know where to find these. These are under math and PRB. And you have to put the first number in. Like to do this NCR up here, I would do 6, math, PRB, pick NCR on my calculator, and then 2, and then press enter, and it would tell me 15. So if I want to place those in order, let's say I've got 6 and I want to choose first and second place. If I'm choosing first and second place, or maybe you're doing a marathon and you want to know how many different ways you can have the first 6 places, anything that would put something in order, and the order makes a difference, we'd use NPR. Math, PRB, and then NPR. So 6P2. So 6, math, PRB, NPR, 2. 6 place in order, 2 at a time. Gives me 30. We see this a lot of times with how many different ways can I rearrange the letters in such and such a word. That gives us something called a distinguishable permutation. If I take the word goal, 4 letters, how many ways can I put them in order? Well, 4 place in order, 4 at a time. If I'm putting all of them in order, if this number and this number are both the same on a permutation, I can also use a factorial. So 4 factorial. That's also under math PRB. So you do 4 and then this exclamation point. Equals 24. Well, but here's the problem. Mississippi. How many distinguishable permutations does it make? Which means I've got to be able to tell them apart. And if I just switch these 2 S's, I can't tell them apart. They're not distinguishable. So if I've got duplicates in a problem like this, I would first of all do, there are 11 letters in Mississippi, so 11, place in order 11 at a time. That gives me 39,916,800. But I've got to divide out the duplicates. There are 4 I's, so I divide by 4 factorial. There are 4 S's, so I divide by 4 factorial. There are 2 P's, so I divide by 2 factorial. It gives me 1152. So the total here is only 34,650. Now, if you type all of this in your calculator at one time, be careful. Remember, parentheses. If you don't put those parentheses, it's going to divide by 4 factorial, multiply by 4 factorial, divide by 2 factorial, and you're going to get almost 20 million there. And that's going to be way off. Make sure you put parentheses around your numerator and your denominator anytime you're doing fractions in your calculator. All right, quick review of anything having to do with probability here. So you're going to want to make sure that you understand these for your EOC.